This is lesson 3.1 on using exponents to describe numbers. This is the first lesson of chapter 3, which is on powers and exponents. A couple definitions to start. A power is a way to show repeated multiplication. So instead of writing 2 times 2 times 2, you can just write it as 2 to the power of 3, which is equivalent to 8. So it saves time and space because you don't have to write all of the repeated multiplication out. You can just write it like this. There are two parts to a power. There's the base number and the exponent number. The base is the big number, or the number that's being multiplied. So the large number underneath, in this case, is 2, and that's the one that's being repeated over and over. The exponent is the little number that goes up top, like 3 here, and this is the number of times that the base is being multiplied. In this case, 3. So in these examples here, the big number is the base, so 2, 4, and 12, and the tiny number up top is the exponent, 3, 5, and 3. The exponent is representing how many times the base is being repeatedly multiplied together. A common mistake that people do with exponents is they think, okay, 3 to the power of 4, this is 3 times 4, which I know to be 12. But that is not how you work with exponents. It's important to write out the, 3 to the 4, write it out as 3 by 3 by 3 by 3, which is going to give us 81. Once you practice with exponents a lot, you'll memorize some of these off the top of your head, so you won't have to write it out like repeated multiplication every time, but this is what it's representing. It is not multiplying those two numbers together. It's very different because this tiny number is up top. It is the exponent. It's this base number to the power of that exponent number. A couple examples. So if we have 1/2 to the power of 3, this is in brackets, so this power of 3 is being applied to the whole thing. So we just take the base, 1/2, and we write it out, or we repeat it as many times as the exponent is. So 3 times in this case. These are getting multiplied together. We don't have to write the multiplication symbol in between there. When there's brackets and they're beside each other like this, it's just representing multiplication. We know how to multiply fractions, so all the numerators get multiplied together, all the denominators multiply together. That gives us 1/8. There's another trick you can use when you have fractions and exponents. You could just distribute the exponent into the brackets. So 1/2 to the power of 3, you can just put this power of 3 with the numerator and with the denominator. So 1 to the power of 3 over 2 to the power of 3. Then calculate those individually, 1 and 8. You don't have to do it that way, but it can be convenient. So for example, 2/5 to the power of 4 is the same thing as 2 to the 4 over 5 to the 4. And then you could use your repeated multiplication to figure out what that is. When we're working with negatives, it can be a little different. In this case, this is all, the negative 7 is in brackets. So that means the exponent applies to everything in the brackets. So our base is -7. It's being repeated 4 times, so we write it out, multiplied together 4 times. When we're trying to calculate this, it can be helpful to chunk. So we know what 7 times 7 is, so I've chunked it into 2 bits of that, 49 and 49. Reminder that a double negative, when we're multiplying, gives you a positive. So -7 times -7 is positive 49. Then on the side here, I just did the long multiplication to figure out what 49 times 49 is, and it's 2,401. Numbers, when we're working with exponents, the numbers get really large very quickly. If you've ever heard of someone talking about exponential growth, that's when something's growing really, really quickly. So yeah, you had 7, and when you multiply it by 1/7, that's not so much, that's 49. But as soon as you multiply it by 7, and then by 7 again, it's quickly getting a lot higher. Now, this is something important to differentiate. This is almost the same question, but you'll notice there are no brackets in this problem. It's -7 to the power of 4. This means that the exponent only applies to the 7, not to the negative, because there are no brackets here. So this is going to give us a different answer. We leave our negative out front, and then we calculate where we do the repeated multiplication. Their base is 7, so 7 by 7 by 7 by 7. We already calculated that to be 2,401, but it's important to note that this negative is here because the negative's out front here. So I wrote in big red letters, understand why this is negative and the example above is not. And the difference is the first example is in brackets, so the exponent applies to the negative, and the second example, it is not that way. 2 more quick examples. Write 8 times 8 as an exponent. Well, the base is 8 because that's the number being repeated, and it's being repeated 2 times, so it's 8 to the power of 2. And the last one, write 10 by 10 by 10 by 10 by 10 as an exponent. The base is 10 because that's the number being repeated, and it's being repeated 5 times, so it's to the power of 5. So you can see how much easier it is to write this than this. And as the numbers get larger and larger, you see how much more convenient it is to work with exponents instead.